Hey y'all! Today's lesson is on rates and proportions. I know that you've reviewed proportions before, so I'm going to just show you a few quick things. A rate is a ratio of two different things that have different units. For example, the speed. If you drive 50 miles per hour, you have miles and you have hours, so that's a rate. Another rate is if you get paid. If you make $30 an hour, that is a rate. A unit rate has a denominator of 1. So a speed limit, 65 miles per 1 hour, is a unit rate. Also, if you go to the grocery store and you buy something, it might be, eggs might cost $1.20 per dozen. So that would be 12 cents per 1 egg. And 12 cents per 1 egg would be a unit rate. And then a proportion, two equal rates. So A over B is equal to C over D. B and D cannot equal 0. And then you're going to use the cross products. You're going to multiply AD and BC. When you multiply the cross products, those are equal. So we're going to work a little bit first with, find an equal rate. So I've already gotten some work. So pause it, copy this down. If you see something that says 32 ounces is 1 serving, but they want to know how many pounds per serving, we need to convert it using equivalent rates. And the way that we do that is, I don't know if you can see the red, I've shown you how to set up equivalent rates. I start with the first one, I end with the last one. So you see the first and the end are the same. My middle one is the conversion rate. That's when I'm going to change my pounds to my ounces to my pounds. So 32 ounces over 1 serving, and how many pounds is 1 serving? And I know that there are 16 ounces in 1 pound. Now, if you notice, I have to put my ounces diagonal from each other so they will cancel. So do you see ounces, ounces? My ounces will cancel, and 16 will go into 16 1, and 16 will go into 32 twice. Now I can multiply. 2 times 1 is 2, and 1 times 1 is 1. So for 32 ounces, it would equal 2 pounds per serving. So that's how it works. Let me show you B. We're going to buy something that's going to cost $1.44 for every foot, but we want to know the cost per inches. So I start with my first rate at the beginning, $1.44 per foot, and my second rate goes at the end, cost per inches, and my conversion goes in the middle. I know that 1 foot is 12 inches. Notice my feet have to be diagonal from each other so they can cancel. 1 foot cancels with 1 foot, and I'm left with 12 inches. And now I'm going to divide $1.44. See, it's divided by 12, and I know that I'm going to pay 12 cents per inch. Ooh, can't really tell that. That's 12 cents per every 1 inch, or just 1 inch. And so I've canceled my feet out. So let me show you this one. 100 times per second. I don't know what can go 100 times per second, but something is moving 100 times per second, and I want to convert it to how many times per minute. So again, I start with my first rate and my third rate. And my conversion, since I'm changing my seconds to minutes, notice I have seconds on the denominator, and then my seconds go in the numerator. 60 seconds equals 1 minute. My seconds cancel. And now I'm going to multiply 100 times 60, so 6,000 times for every minute. If it can rotate 100 times in 1 second, it's going to move 6,000 times per minute. Oh, and this is, not 1.2. 12 cents for every inch and 6,000 times. So these are using equivalent rates. Okay, let's go to the next set. All right, copy these down, pause it, write and solve an equation. Copy and pause. A beetle weighs that much ounces, but can carry 446.25 ounces on its back. If a person were proportionally as strong, how much could a 100-pound person carry? So a little beetle can carry a lot of weight. So we need to write our first rate. It weighs 0.525 ounces, and it can carry 446.25 ounces. This is its weight and how much it can carry. This is proportional, so I'm going to write a proportion. It's proportional to a person, a 100-pound person. So should 100 pounds go with the weight of the beetle or should it go with the carrying? And it should go with the weight of the beetle. And then our variable is going to go in the denominator. Now, you should use a calculator. And we're going to find the cross products. We're going to cross product 0.525 times x. And this times 446.25 times 100. So it's going to be 446.25. And then we're going to divide. And I'm using my calculator, so we will be using calculators in this. Whoa, did I do that right? That seems like way too much. Let me check. So 446.25 times 100, and I'm going to divide it by 0.525. Whoa, so this says a person, if we were proportionally as strong as a beetle, then we could carry 85,000 pounds on our back. And I got that by setting up a proportion. All right, let's do B together. Jesse's car can go 380 miles on 12 gallons. So 380 miles on 12 gallons. About how many gallons will her car need for 2,000 miles? Well, 2,000 miles is going to match up with 2,000 miles is going to match up with miles, and we're looking for X number of gallons. I'm going to cross multiply 380 times X, and it's going to equal 2,000 times 12, so 24,000. Divided by 380, and it says about, so we're going to round, and it looks like we're going to need about 63.2 gallons of gas. 63.2 gallons of gas. Now again, I'm setting up my proportions, and then I'm cross-multiplying to solve them. All right, let's go to the last few examples. All right, pause it, copy it down. All right, a blueprint for a house is 50 centimeters wide. So blueprint is what the architect draws it on blue paper before it's built. If the scale is 1 centimeter to 5.5 meters, how wide is the actual house? So if you have a scale problem, you're going to start with your scale in your proportion. 1 centimeter is to 0.5 meters. And then 50 centimeters is going to go on top with centimeters, and we're looking for the actual. So we're looking for the meters. I'm going to cross multiply. 1 times x is x, and 0.5 times 50 is 25 meters. So that means our actual house is going to be 25 meters if our scale is 50 centimeters. Okay, so letter D, a scale is 1 inch is to 50 feet. 1 inch is to 50 feet. Make sure you're writing all this down. For models, find the model's height for an object that is 800 feet. So 800 feet will go down the denominator, and we're looking for the model's height. So we need to look for inches. We're going to cross multiply 50x equals 800. And then you're going to divide by 50, and so I believe it's going to be 160. Let's see. 800 divided by 50. Oh, 16. Whoops. 16 inches is the model's height. You're going to divide by 50, and you get 16 inches. So I know these are really quick. All right, so let me show you the last few. Multi-step proportions. Multi-step proportions. We're going to use the cross product. We're going to multiply and then solve an equation. So I'm going to multiply. Okay, watch carefully. Just like I did them before, I'm going to cross multiply, and I'm going to do 40 times x minus 2 equals 8 times 30, which is 240. Now I have a multi-step equation. I'm going to distribute 40x minus 80 is 240. I'm going to add 80 to both sides. 40x equals 320, and x equals 8. X equals 8. I know I'm going through these fast, but these are multi-step equations. Let's do B together. On B, I'm going to cross multiply again. And x times 7 is 7x. And 5 times this is 5 times x plus 4. We put it in parentheses. We need to distribute. When I distributed, I got 5x plus 20. Now I have variables on both sides. We know how to solve variables on both sides. We need to subtract 5x, and I get 2x equals 20. And we know that if 2x equals 20, then x equals 10. And again, the nice thing about equations is we can always go back and double check. All right, so let me show you C. I'm going to show you one more. We're going to cross multiply. So I'm going to say 9 times this whole thing and 4 times that whole thing. So 9 times 3 minus 5x equals 4 times x plus 5. I've done the cross product. Now I'm going to distribute. 27 minus 45x, 4x plus 20. I have variables on both sides, so I'm going to subtract 4x to move it over. And this gives me negative 49x. And then I'm going to subtract 27. And that's going to give me negative 7. I'm sort of running out of room. I have to divide both sides by negative 49. And a negative divided by a negative is a positive. And 7 over 49 can be reduced. Divide by 7. So my answer is positive 1/7. Now, if I wanted to check, I would take 1/7. I would plug it in up here, and then I would make sure my two sides were equal. So that was, very quickly, rates and proportions, and we'll practice more in class.